Hey peeps, it's Jedd here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're going to deal with a probability question, and with that in mind, we're going to dive straight into it. So they've said to us, in a random physical sciences experiment, A and B are two different events. It was found that the probability of A occurring is 2 over 5, the probability of B not occurring is 3 over 8, and the probability of A or B occurring is 5 over 7. Now in 8.1.1a, they've asked us to calculate the probability of B. Now they've given us the probability of B not happening. Now we know for an event to be certain to happen, it would equal 100% or 1. So the probability of an event not happening would be 1 minus the probability of that event. So to use that scenario, we're going to say the probability of B must be equal to certainty minus the event not happening at all. So that would leave us with the probability of it happening. So that's going to be 1 minus 3 over 8. And that is going to give us a probability of 5 over 8. And that gives you the full marks for that question. Brilliant. Okay. So now we move on to 8.1.1b. which is slightly trickier, but I have no doubt you're going to get this one. Right, so they've asked us to calculate the intersection of the two. Now, we've got a nifty formula that you really need to remember, and that nifty formula is that the probability of both events occurring, or either of them occurring, okay, so it's the union, or if A occurring or B occurring, is equal to the probability of A occurring plus the probability of B occurring minus the probability of of both of the events occurring at the same time. Okay, now we need to plug in all of the stuff we know. So they've given us the union, or A or B, and that's going to be 5 over 7. The probability of A, they've said to us, is 2 over 5. And we already calculated the probability of B occurring, which is 5 over 8. And that leaves us with one unknown, which is exactly what we want, because now we can use our equation rules to get this by itself. So what we would do is we would take those two across the equal sign, we'd then divide by a -1, and that would ultimately lead us to obtain an answer of 87 over 280, which is approximately 0.31, and that gives us the probability of A intersection B. Now we move on to the last question for this particular section. They've said to us, hence, and hence is always a nice word because it means using what you've just done, determine whether events A and B are mutually exclusive. Motivate your answer. Now, let's just try and think of what mutually exclusive means. If we think of it in terms of a Venn diagram, mutually exclusive events are events that don't have an intersection. They're separate from each other. So the the probability of A intersection B would have to be 0. But we've determined in this case that the probability of both events occurring at the same time is actually equal to 0.31, which is fairly high. So in this instance, for 8.1.2, we would say that they are not mutually exclusive, and the reason for that is that the probability of A intersection B happening is not equal to 0, and that would get you the full marks for this question. Really good job. Very special thank you to our sponsors for making this video possible. Remember to find more of these epic tutorial videos on our website. If you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. Until the next time, stay epic.